So welcome, everyone. Thanks for coming out to this user group meeting today. My name is JD Maloney. Like you said, I work at NCSA, the National Center for Supercomputing Applications, not the National Collegiate Sports Association, for those that are confused. If you Google, watch out. I'm going to talk today about some of the ways that we accelerate open science and commercial workloads at NCSA. I'm going to start off with some of the things that we're working on as a center, some of the things that are keeping us busy, and then also transition into how DDN is helping us solve those problems, go through a few of the use cases that we see as an open science HPC center, but also that are not unique to open science HPC and are things that you guys see in commercial research also. So first off, just an intro to NCSA. Like I mentioned, that's our acronym. We operate the National Petascale Computing Facility, and we're a non-degree granting unit at the University of Illinois. Where are we located? So Champaign, Illinois, aka the middle of a cornfield somewhere in the Midwest. So that's where we're at. And where do we come from? We are one of the original NSF supercomputing centers that were founded back in the late 80s as part of the Black proposal. And we've deployed over 30 supercomputers for both open science and commercial partners. And so I'm going to talk about a little bit here what we're working on. So first is we're wrapping up Blue Waters. It ends its open science missions here at the end of this calendar year. We're transitioning it to support some work for the National Geospatial Intelligence Agency. That was part of an $11.1 million extension of the system. We will be transitioning it to do a lot of geospatial work for them. So you guys might remember we did Arctic Dem as part of an Obama-era initiative to map the Arctic at ultra-high resolution. We're going to kind of do that for the whole world now as part of that with these guys. So the system will also be allocated 10% for Illinois researchers, too. So for the next year, Illinois researchers get access to Blue Waters for high-scale computing needs. So also, we have the NCSA Industry Program. We currently have 30 partners and more coming. I had to check on that number because trying to figure out where contract negotiations are with certain ones. We have a lot of workings with a lot of private sector companies across all sorts of science domains, which allows us to get exposure not just to things that we see in open science workloads, but also problems that we see that are unique to commercial research as well. So we have a lot of partnerships across all these domains, and we're also providing a lot more services to these industry partners, not just HPC, but also things like big data analytics and things like that. So also, we're working with LSST. We've been operating the development systems for them as they ramp towards the production of their telescope, which expects to be operational in fall of 2022. It's a large instrument, of course, 3.2 gigapixel camera, the largest camera, I believe, still in the world at this time that's been announced. 20 terabytes a day will come off that instrument. And right now, we've been working with them. And there's going to be some infrastructure at the base down in Chile. So we're taking trips to Chile. I might be going down next year. We have some DDN equipment already deployed in Chile. I'd like to think we've been talking with, I think Mark Capana has been helping us on the support side of that and working through all those things in South America to figure out how to get parts in and out of that country. So that's been a fun experience. Also, NCSA has the software directorate. It's a new area of NCSA that we've kind of partitioned off and are restructuring. And so they're a large division of who we are. It comes from that A in the applications in our name. And so we manage over 35 different projects that represent over $30 million in funding. And those are some of the common ones that had images for them. And these projects are a lot of open science funded things, but also they're ones that we take from open science and then convert into industry things. So Clouder, for example, you see there was an NSF funded software project, but we're now actually working with industry partners and deploying instances of that software product for them in our data center. So there's that bleed between open science work and also commercial work. And also lastly, we're at the University of Illinois. Illinois is a very large R1 research institution with over $658 million in research expenditures last year alone. And we're home to 9 major research institutes, of which we are one. And we also operate Research Park, which has 120 companies and startups of varying sizes, everything from the large, super big ones like John Deere's and Caterpillars and stuff, all the way down to new companies that I don't even know because they're just starting out. So they're at the Research Park. So there's a lot of research stuff that goes on, and a lot of researchers demand stuff on the campus of Illinois. So that's kind of what we do. The next thing I'm going to kind of jump into are some of the problems that we see and how we solve those with DDN hardware. So The first thing is about our storage environment right now. We have 57 petabytes of usable, addressable capacity for users, and that's currently, most of that is DDN, not all of it, but most of it. We also have 15 petabytes of inbound capacity to the center. Most of that's actually on the floor. Some of it's in flight. We got one last 14KX that's going to roll into the data center any day now. And so by the end of the year, we're going to be up over 70 petabytes of usable space. Users are consuming about 37 petabytes. That's a little bit of a misnomer. Some of this inbound capacity is going to be filled upon arrival. We're actually going to take these units in, and they're just going to get almost filled up. So we're going to cross probably over 50 petabytes used here pretty soon. And that consumes across 12.6 billion inodes currently in the center. So a lot of inodes to keep track of. So what do we use? I thought about being cheeky and just putting the word all of it on here. We have a lot of DDN's products in the data center, everything from the 18K to the 400NV, 14KXs, 12KXs, 7990s, and the 7700X. That's what we have active serving production. We have 10Ks, 7000s, everything going back. We've had a long, good relationship with DDN, so if they make it, it's kind of in the data center mostly for a lot of things. So we are currently using all these things in some capacity. And I think the 7990 is what we have down in Chile right now. So that's what we're using. So I'm going to kind of go through some of the different systems that we're using that with. So the first one is AI and machine learning. A lot of us are dealing with that. The first speaker in pharmaceuticals was talking about that. It's a big area. A lot of us are seeing it everywhere. So we're seeing it in Illinois. Everyone's seeing it everywhere. It's not unique to us. Everyone's having to deal with that. So NCSA was awarded an MRI grant from the NSF to build a system that helps provide a platform for researchers to develop these AI workloads and do those types of activities. So we provisioned a system called HAL. It's an IBM AC922-based system, so the same architecture they used in Sierra from a compute perspective. And the project actually did not procure storage right away. They actually took delivery of compute and network and used a little NFS NAS box as the starting file system just so they could see what users were bringing into the system, what type of I/O they needed, what they were looking for the file system to provide them. And they took that data, and then we ended up deriving a solution. So right now, we have 2 SFA 400NVEs in that file system. We're looking to get a 7990, but it might be a 7990X now. I saw that press release. So that was after I sent my slides in, though. So certain file sets are pinned to these 400NV units, and the others we will let tier between the 400NVs and then down to the SFA 7990. So a lot of data sets we see are very large, but they're used to train, and then they get kind of cold for a while. So that's where that tiering is going to be very helpful. So this has been very helpful for users. They love it a lot. The ability for them to actually drive the file system for their benchmarks. We did a lot of work with DDN on this system. We actually had the lab do some benchmarking that wasn't your standard IOR and MD test. We had a PhD student at the university had developed his own AI-based benchmark that was part of his thesis, and we actually used that in the lab, ran it. The lab loved it. Apparently, I was talking to one of our DDN guys today, and the lab actually wants to use that benchmark for some other stuff. So we actually went through an extensive POC with DDN on this, and it came out pretty well. So that's what drives this environment for us right now. Another one is big data and prompt processing. So along with the telescopes, these satellites that we're seeing from all these government agencies, there's a lot of stuff that needs real-time processing, not stuff that we're used to in traditional HPC, right? You need to process your data from the telescope. Yeah, just wait. Your job will start in 12 hours. That's not acceptable for certain things. And so there's a lot of projects that we're seeing an increased uptick in that need real-time processing requirements. They need the data, and they need the data now. But there's a lot of them, and we don't want to provision a system just dedicated for them because that's wasteful. So building a shared system that can accommodate this has been very helpful and also host other things. So we're in the middle of provisioning a new system called Radiant that's going to provide that elastic compute capability. I think we actually have a rack and stack party when I get back next week. So we're going to rack the system, go eat turkey, and then come back and get it running. So the storage is backed by our NCSA storage condo, which is an Ethernet-based file system. So right now, that is composed of 2 12KX units and an 18KE that we just got. We're transitioning this environment to all embedded. You'll notice on the 12KXs are block appliances, but as those units go off of support and we move things in the 18K environment, we'll likely continue to embed in this place because it's worked out really well so far for us. So we also leverage export services. A lot of those things that we see in this elastic compute environment don't talk native. Maybe they want to run containers on their own VM, and we can't let them have root on the file system. So we need to do NFS or Samba, leverage export services. And so it's not just going to be native mounts in there. So this is kind of the environment we're using to build out. That's a lot of capacity, but not extreme performance, just reliability. Data is always available. They need it to be up because there's data coming in from those instruments. They need to keep it going. So that's the big data side. The last one that I'm going to talk about is HIPAA and PHI. So we have a good, strong relationship with institutes that need this type of data stored. And so whether that's from some of our industry partners or it's from medical colleges or some other things like that, pharmaceutical companies that are in our industry program, they have a lot of data that is governed under HIPAA. It has PHI in it. I imagine a lot of you guys are seeing that in your institutions too. And it's not easy, right? It's to do these types of things and comply with this. So we're seeing this requirement everywhere. So we've created an environment called AIC, which I think is appropriate for health. We all laughed when that came through. Who decided that idea? But it's the Advanced Computational Health Enclave, and this enclave has been built to service this need, both from a data perspective, but also from a compute perspective. So we've been working through it. Of course, all the infrastructure in here is HIPAA compliant because it has to be. We're also going through SOC 2 Type 2 audits. Some of you might be familiar with that. So we're spending a lot of time with like accountants and lawyers and people. I'm not used to that as an engineer. It's a little weird. They ask different questions. But yeah, so we're going through that. But it's very important because these are requirements that we need to answer. So, so our environment right now is, I said 3 14KXs. The third one's coming. It's not in the picture. So it's on its way. It's shipping to us. It's an all EDR-backed IB cluster, and we're preparing to offer full file audit logging to comply with different requirements that we need. Also, there's the 12KXE that I mentioned there. We've actually, like the Amazon Snowball that you read about, we actually made our own little Snowball. We used a DDN rack embedded to do it. It was great because you can drop it into a customer's data center that needs to ship you a bunch of data, and then it can do NFS. If they need NFS, we can do native mount if they need a native mount to transfer that data in. Because a lot of these customers, especially in HIPAA PHI, their networks are very locked down, and for very good reason. But we did the math. It's like, yeah, so 12 years will get your data in. That's longer than like twice as the contract length that we have with you. So that's not going to work. So we actually did that. You take the 12KXE, you have the controllers in one truck, the enclosures and disks in another truck, the encryption keys in a third truck, in the van that you're driving, and then that actually is safe. And so that's actually how you bring petabytes of health data into your data center. So we've actually done that with a couple of customers. Yeah, so it's a DDN on wheels, I guess. So, but yeah, so that's not in production use right now. Well, it's in production use, but not in the main file system capacity. We do use SED drives for these, so it's all encrypted on the disk, not at the file system level. We have we worked with DDN on how we deal with the hard drives when that happens, right? Because you can't just ship back, even though they're encrypted, people are sensitive about sending those back. So we just have a black box that they go into our place. We say there's a dead drive, we need a new one, and you're not getting the old one back, sorry. So we've worked that out. But this is a really big area for us. As you notice, it's 16 petabytes just in that. That does include when that 14KX comes in, but that last 14KX won't be fully populated. If you find me next year, I bet I will tell you that number is a lot bigger. I'm seeing 10 terabytes a day right now, net growth on this area. It is massive. So we have a lot of data to protect there, and it's been a really, really big and fun area for us to kind of deal with. So that is all I have. Does anybody have any questions about that? There we go. We've gone cold on questions here today. So,
Is this one on? Yeah. So how long have you been at NCSA?
5 years.
And then have you been the one responsible for acquiring all this DDN kit, or you just
No,
join it?
it preceded me.
Yeah.
It preceded me. Yeah. So
Okay. So what are the...
I remember my first day actually walking in, and someone would say casually, like, 12K. And I'm like, what's 12,000 what? What's 12,000? I don't understand.
DDN, what?
Yeah, I didn't understand. Yeah. So absolutely not.
So out of all the challenges that we've got around, let's say, data management, security, and performance, just those three, which one would you put at the top of the pile in terms of where you need to improve? Or where the storage needs to improve?
So what were your three again?
Data management, security, performance.
I think management, quite honestly. It kind of goes back to what Sven was talking about with Red, and we've talked to DDN about that already. But it's the same thing. We have customers who want things always up. Kind of like what drove us to build Radiant here is that managing data, it needs to be everywhere on every system all the time, always up is kind of the thing that we see the most. Of course, protection is important to the very select people, but for our main mission, which is open science, they're not protective of it. They're almost, like Luster and Spectrum Scale run as root, and that prohibits a lot of things. We're like, well, we don't need to run as root. I trust my friend Bob over here. He's over at another university. And we're like, so that management I think is the biggest thing for us.
Yeah. Good. Well, that's a nice entry into my talk.